Hi folks, it is time for science, and this is your daily screencast for Monday and Tuesday, March 4th and 5th. I'm coming from a slightly different location because I procrastinated a little bit, but it's alright. We're getting it done anyways. So, today you're going to understand reaction classifications and formula mass and how to actually use the mole. So last week we got to introduce what's a mole, what's Avogadro's number, and we kind of put this idea out there that it's this really important number for chemistry, but how do we actually use it? So that's what we're going to be doing today. Not only are we going to talk about classifying reactions, but we also get to talk about how do we actually use the mole. So very similar, we're just going to have you kind of go through the notes and submit the kind of practice to Schoology as some pictures. Whether you're uploading the pictures just by themselves or you're putting them on a document, doesn't really matter as long as you have some sort of proof that you're doing the work. Other thing to think about today is you're going to keep marching along with that PhET project, and this week the PhET to think about is the reactants, products, and leftovers. So let's go into Schoology and take a look at everything that you'll see when you go into the folder for week of May 4th. So we have our agenda here, which I was just showing you. We have a screencast. Don't forget those attendance questions. Thank you for most of you for getting those done in a really timely manner, so I can make sure to record attendance, and I also just enjoy reading them. Especially the favorites one was really cute last week. I really enjoyed reading, like, what was the thing that was your favorite for one, and what did you choose to actually say what is your favorite thing out of any category. So that was really fun. I enjoy those questions. So other thing you'll see is a nice little link directly to the reactants, products, and leftovers PhET. It will bring you directly to that web page if you click down here. But what we're interested in is taking a look at the classifying reactions and the mole. I'll talk a little bit about the PowerPoint here in the screencast and what you're going to be getting out of these notes. So we have the note taker here. You should have it in your packet, and you'll be able to fill it in on the hard copy and take some pictures. And then this PowerPoint will help you actually see that. So let's pull up that PowerPoint and we'll talk through it just a little bit. So it's going to contain about 3 pages. This first page is some notes here, as well as some more practice later, and then a couple more notes that we'll fill in kind of as a part 2. So we start off talking about true and false. Take your time, read through them, make your guesses, and then check them on the PowerPoint. And then we talk about a couple of different reactions. And so we have about 5 different types of reactions. We have our addition reactions, decomposition reactions, single displacement, double displacement, and combustion. So addition reaction is where we're taking 2 different elements and we join them together in one molecule. Decomposition is the opposite, where we have 2 elements joined together and they break apart. We also have our single displacement and double displacement, where we have 1 atom and a pair, and then they switch off. And then double displacement is 2 pairs, and they both kind of switch. So I kind of like to talk about these reactions like you were going to a dance. And addition reaction is basically like one person goes to the dance single, another person goes to the dance single, and in addition reaction, they end up at the end of the dance together. Decomposition is where you have a couple, they go to the dance, they have a fight, and then they break up, so they're both single at the end. And it gets even weirder when we start talking about single displacement reactions. So in single displacement reactions, imagine having one single person going to the dance, and then a couple. And this one single person starts dancing with one of the 2 in the couple, and then these couples stay together, and the original date that they started with now gets kind of booted off and is now the single in that reaction or in that dance pair. So a little sad for that one that gets kicked off. Double displacement is a little bit better because you have 2 couples And even though one couple interacts with the other pair, they find out that the other couple, oh, I like this person better too. So they both end up with different partners than they started with, but they're both still happy about it. The last one that doesn't quite fit into that analogy is the combustion reaction. And combustion reactions are actually pretty straightforward. Your big indicators that you have a combustion reaction are going to be having oxygen here on the reactant side, as well as on the product side, you're going to have water and CO2. So if you see water and CO2 on the product side, that is telling you that that is a combustion reaction. So, have some practice. Again, as always, I have this here with all of the answers you can go through, but I do expect you to attempt it and then check yourself. After that, we move into formula, mass, and the mole. So this is essentially part 2 of the notes and lecture, where we start talking about how do we get a formula mass, what is a formula mass. Basically, it's just adding up the atomic masses of each element of the periodic table. So this is another place where these atomic masses come in. Don't get it confused with the atomic number. Remember, atomic mass has both protons and neutrons. It's going to be the bigger number in any given cell on the periodic table. So, basic way that you count it is you have your elements in the substance. You have to name how many you have. There are 2 hydrogens, so you multiply its atomic mass by 2. So they're contributing about 2.016 to the formula mass. There's 1 oxygen with an atomic mass of 15.99. You add these 2 together and you get 18.06. So basically you're just adding up all the atomic masses based on how many there are to find this formula mass. So, something that's really cool about this formula mass is that this is also how many grams are in a mole of a substance. So this is a really cool thing that Avogadro kind of figured out with his mole number, his mole unit. So 1 mole is equal to the atomic mass, and we know that there's also 6.02 times 10 to the 23rd molecules if we have that mass of the substance. So for example, if you have 18 grams of water, then that tells us that we have 1 mole of water as well. And so this is great because we can use this as a conversion factor, and we can figure out in any given substance how many moles that we might have, how many grams we might have if we're giving something, and this takes us back to good old DA. So if you still haven't learned DA yet, now is a great time to review that. And we're going to be working with some slightly different units. And these conversion factors are going to change based on what molecule you're working with. So 1 mole of water is equal to 18 grams, but a mole of another substance like salt is going to have an entirely different conversion factor. So it gets a little tricky. But this allows us to solve problems like how many grams would you have if you had 10 moles of water? And we can just use this conversion factor and figure out that you'd need 180 grams to have 10 moles of water. And we can make the same conversion backwards. If we're given 1 gram of water, how many moles do we have? And then the other thing that I talked about that we needed to know scientific notation for was those numbers of particles. So we can figure out how many particles of water are in this 1 gram of water, 0.055 moles of water. And I think it's amazing that even that tiny, tiny amount of water, 1 little gram, still has hundreds of thousands of molecules. 10 to the 22, that's huge. So, just something really cool that we can use and apply what we've learned already with moles and Avogadro's number. So these are your big equations to know. These will help you sort of understand how to convert moles to grams, grams to moles, and number of particles. Just plug in what you're given, number of moles, molar mass, you'll have to figure out. But it's not too bad. This video here will explain it a little bit more slowly and kind of walk you through some practice problems. As well, I'm going to be kind of working through these during the class time Google Hangout. So the rest of the worksheet is kind of this big table here. Like I said, answers are here. This is a great thing for you to check, but it's not necessarily there for you to just copy. So do try these out. Try figuring out the formula mass and the moles and everything for these example molecules. So that is it for today. Make sure that you get the assignment complete. Take some pictures of it and submit it to Schoology by Friday. And then last thing is to remember to be working on that PhET. You're almost done with the PhET project. Your next 2 PhETs will actually be your choice. So you're nearing the end pretty quickly. That's all I got for you today. As always, I'm available for questions during class time or during office hours. Please feel free to reach out if you have any questions or concern. But until then, we'll see you next time. Bye!